Hi, good morning all. Today we are going to discuss inverse Laplace transform. So we have already discussed in our previous classes the definition of Laplace transform and Laplace transform of some basic functions. For example, Laplace transform of, I will give you some of the results we have studied. Laplace transform of 1 equal to 1 by s. Laplace transform of t equal to 1 by etc. 1 by s square, etc. like this. So, and also we have studied the using the properties of Laplace transform, how to find the Laplace transform of various function like that. So that we have already discussed in our previous classes. So today, first of all, I will give you the definition of inverse Laplace transform. What is an inverse Laplace transform? So its definition is as follows. If Laplace transform of f of t equal to f of s, then this f of t is called the inverse Laplace transform. Inverse Laplace transform of f of s. Simple. We know that Laplace transform of f of t is it will be a function of s, so we usually denote it as f of s. Then this f of t, the original function, is called the inverse Laplace transform of f of s. So there is a lot of methods to find the inverse Laplace transform of certain function. Sometimes we will be given a function of s and we have to find out its inverse Laplace transform using different methods. So I will give you some examples using this definition how we can find the inverse of certain function. We have already studied like this. Laplace transform of 1 is 1 by s. Therefore, inverse of 1 by s is clearly 1. Laplace transform of 1 is 1 by s. Therefore, L inverse of 1 by s is equal to 1. This definition. Using this definition. Similarly, Laplace transform of t, we know that 1 by s square. So, what is the inverse of 1 by s square? 1 by s square is therefore t. Now, Laplace transform of t square, we know that 2 factorial by s cube. Therefore, L inverse of 1 by s cube is equal to t square by 2 factorial. Like this. So, in general, Laplace transform of t raised to n, we know that it is n factorial by s raised to n plus 1. Therefore, inverse of 1 by s raised to n plus 1 is this t raised to n divided by this constant n factorial. Clear? So similarly, we have studied Laplace transform of sin at. What is it? It is a by s square plus a square. So, what is the inverse of 1 by s square plus a square? We will take only the function of s. This a is a constant. So, inverse of 1 by s square plus a square is sin at divided by this a constant. It is simple, just like integration and differentiation, like that. So, Laplace transform of next result, Laplace transform of cos at. It is s by s square plus a square. That we know. Therefore, inverse of this s is s by s square plus a square is cos at. Clear? Similarly, Laplace transform of what is e raised to at? 1 by s minus a. So, inverse of 1 by s minus a equal to e raised to at. Clear? So first of all, you should thorough these results. Then only you can do the problems of this section. So Laplace transform of e raised to minus at. What is it? If there is minus comes, then the answer in 1 by s plus a. Laplace transform of e raised to minus at is 1 by s plus a. Therefore, inverse of 1 by s plus a will be e raised to minus at. Then Laplace transform of one more function, hyperbolic function. Laplace transform of sin h at equal to a by s square minus a square. So the inverse of 1 by s square minus a square will be, yes, sin h at divided by this constant a. Now Laplace transform of cos h at equal to, what is that? S by s square minus a square. So the inverse of s by s square minus a square equal to cos h at. So these are the basic functions that we have studied. Remember. Now I will give you some explanations how to find the inverse Laplace transform using this. Do you remember the first shifting theorem? What is the first shifting theorem? If Laplace transform of f of t equal to f of s, then Laplace transform of e raised to at into f of t equal to f of s minus a. That we remember. So I will give you an example. First problem, find the inverse of 1 by s plus 2 the whole square. First problem, find the inverse of 1 by s plus 2. Find the inverse Laplace transform of 1 by s plus 2 whole square. So we know that, listen, we know that inverse of 1 by s square. What is that? Inverse of 1 by s square. Yes, L inverse of 1 by s square is equal to t. That we know. So L inverse of 1 by s square is equal to t. But here instead of s, there is given s plus 2. So you remember the first shifting theorem. S is replaced by s plus 2. That means that function is multiplied with e raised to minus 2t. So L inverse of 1 by s plus 2 whole square we can write as t into e raised to minus 2t. Then only the results will come. So that's why I have given this first shifting theorem. Okay. Clear? One more problem. What is the inverse of s minus 3 by s minus 3 whole square plus 9? Find the inverse of s minus 3 divided by s minus 3 whole square plus 9. So first you should remember the inverse of s by s square plus 9. 9 means 3 square. What is the inverse of s by s square plus 9? That is cos 3t. But here we can see that instead of s, there is s minus 3. That means that function is multiplied with e raised to 3t. You remember this? First shifting theorem. If Laplace transform of f of t equal to f of s, then Laplace transform of e raised to at into f of t equal to f of s minus a. That means we have to replace s by s minus a. So similarly, Laplace transform of, we can say the Laplace transform of s minus 3 divided by s minus 3 whole square plus 9 equal to this cos 3t into, that function is s e raised to 3t. So that is the answer. Clear? So here inverse of s minus 3 by s minus 3 whole square plus 9. Okay.